just gonna look for them. There was one where it's like all the airlines were gonna stop providing complimentary cabin pressurization.
Really? That sounds like a pretty good one. That's what we should do. So people can come to class with like suggestions for these, but they have to be relatively profanity free enough that I can edit. All right. So here we'll read it. This one's not that long. The 4 Americans and 3 Russian astronauts aboard were NASA officials watched in horror Monday as the $68 billion straw space shuttle Explorer 2 burst into flames just after liftoff from Cape Canaveral. The 4 American and 3 Russian astronauts on board were killed instantly despite their protective all-straw spacesuits built by the Amish. Technicians were stunned by the failure, which capped a flawless 6-month pre-launch test period. They count faulty twine among the possible causes of the accident. The straw ship was dry, lightweight, and well bailed enough to break the Earth's orbit, but inexplicably burst into flames when ignited with 3,000 gallons of rocket fuel, said NASA Chief Engineer George Toshikima. This is a devastating setback for NASA. An estimated 30 birds, 8 voles, and 23 mice who were nesting in the ship's outer hull or burrowed homes deep in the ship's straw engine also perished in the blasts. The material holding the ship in place was top-quality burlap baling twine, purchased in bulk from Cape Canaveral's leading farm equipment supplier. The straw ship was constructed with over 200,000 bales of U.S. Grade E straw, baled, tied, and pitched from NASA's Cape Canaveral farm, and stored over the planting season in the launch pad barn. It was nice and crisp and dry, Toshikima said, which is the best condition for straw heading away from the Earth's gravitational pull. According to accident reports, the 1/8-inch thick string was possibly not tied tightly enough or not weaved correctly around a critical fuel delivery gasket, which may have caused the ship to unravel. Toshikima does not believe such a small imperfection could have caused the massive explosion. We are still trying to determine why it suddenly burst into flames, he said. In all the pre-fueling tests, the procedures went perfectly, but as soon as we ignited the fuel, it exploded. Why? Some insiders fault a problem that occurred last week when a section of the ship's starboard high-pressure re-entry tiles was eaten by a horse. The horse should not have been on the launch pad, NASA grounds coordinator Nathan Mearson said. He ate a critical section of the ship, and it set us back 1 full day to rebale and retie that section. Mearson said that the horse was returned to NASA stables and given a suitable meal. Remnants from the department's long-abandoned all-hay Mars probe. Although some reports indicate goats may have gnawed at the ship's exterior cables, NASA scientists maintain that there were never a problem with goats. Explorer 1, NASA's first straw ship, was built in 1994, but after 11 months of painstaking preparation, it was destroyed the day before launch when it unexpectedly rained. The Explorer 2, like its predecessor, was heading to the sun, where it was to be the first spacecraft to land on a star. We'd hoped to bring back and study sun rock, Toshikima said. The straw ship had been equipped with a special reinforced wicker basket to hold the sun lava for its journey back to Earth. A straw-enforced robot arm was constructed to scoop the lava, which is reportedly as hot as the center of a nuclear holocaust, and place it in the wicker basket. The ship's debris is slated to be used as mulch. So what was this other one? Pressurized airlines. Did you
American Airlines.
Complimentary
Pressurization.
Let's just do that.
That's it.
Okay. Is this one like relatively clean?
Yeah.
All right. This is going to be a real-time thing, and the recording has begun. All right, so we'll read this one. This will make up for lost time, then we'll start talking about stacks.
Oh, this is a thing about the article.
We'll find it. Okay. American Airlines to phase out complimentary cabin pressurization. Explaining that the cost of the service have grown too high in recent years, American Airlines announced Tuesday that it will no longer offer free cabin pressurization to passengers starting March 15th. Unfortunately, to stay competitive as a legacy carrier in today's air travel market, it no longer makes economic sense for us to provide breathable air at altitude, said American Airlines CEO Doug Parker, noting that despite the cutbacks, air pressurization would still be available to first and business class travelers, as well as those willing to pay an additional fee. While we regret any altitude sickness, blood problems, dimmed vision, or hyperventilation that may result from the air pressure less than a third of normal levels, we remind our customers that such effects will diminish as soon as the aircraft descends below 10,000 feet. Parker added that the company is also planning to discontinue complimentary landing gear on flights under 4 hours. That's it? They could have gone on with that one. That could have been pretty good. But it left me wanting.
It was either that or the one where it said the German government released an official statement saying that they could perform another Holocaust, that they had the equipment to perform a better Holocaust if they really wanted to.
All right. So, let me... This is 250?
Mm-hmm.
Oh, context. That was a good one. Is that a quiz?
No.
No, I said, should it be a quiz?
He answered no.
All right, so 300. So we already wrote push, pop, and peak. So what was your homework assignment?
To build that.
Oh, just write the same thing we already wrote in class?
Yeah.
Hopefully everybody did it. All right. So, let's solve a interesting math problem using stacks. So let's go with this one. All right. Let's say that I had a formula. 1 plus 3 divided by 6 times 8. Something like that. Okay, and I want to parse this all out. Remember a while ago we wrote process expression? And process expression parsed this out and did some math, blah, blah, blah. Well, I want to parse this out and put it into a stack. Okay. How can that benefit us? If we parse this, we're going to be left with, and let's just give us all of our pieces. There's our 1. Plus 3 to it. Okay, so if these are our tokens, so we read in this string, we tokenize it somehow, read in all our tokens, and now we are left with these elements. These are individual tokens. How can we utilize a stack to effectively do this math? Well, the first thing I'm going to read in is this 1, correct? Well, could I do any math with that 1? I can't. So I'm going to put the 1 on the stack. Then I'm going to read the plus sign. Can I do anything with that? Nope. Put that on the stack. Then I'm going to read in the 3. Well, what happens if I put the 3 on the stack? My stack looks like that, correct? What could I do with those numbers? I can add them up. So I can pop, pop, pop off the stack, do the math, and get what out of that? A 4? Push the 4 back onto the stack. Then I read the divide. Can I do anything with the divide? Nope, put it on the stack. Read in the 6. Since I know the top of my stack is a operator, I can pop off the stack, do the math. 6 divided by 4 is 1. Push that back onto the stack. These are just like fallout pieces. I'm leaving it over here. This is my actual stack right now.
You want to do 4 divided by 6? I mean, if you're going in the order of that.
Oh, I do.
Expression.
I do. Four is on my stack. We put the divide on the stack. We read in the 6. Pop, pop. We'll do 4 divided by 6, which is actually 0, right? Push the 0 back onto the stack. Read in the times. Push that onto the top of the stack. Read in the 8. I mean, you could push it onto the top of the stack and then immediately pop it back off, but since we know the top of the stack is a operator, great. So we'll pop, pop, giving us our final answer, 0. Push that back onto the stack. When we're done reading in things, the top of the stack is our final answer. That make sense? Okay. So let's write this. Right now, my stack knows how to hold numbers. Let's just make sure that it 1 plus 3 divided by 6 times 8. Okay, so our stack knows how to read in those different pieces of information. Now, we are going to prompt the user for an equation. We haven't done that in a while. We haven't read something in from the user in a long time, so we're going to go ahead and do that again. Well, for starters, we're going to get rid of all this crap, because we're going to write that differently this time. And we'll get rid of all this stuff. And I'm going to go ahead and create a scanner called input. This is going to be a new scanner created with system.in. It's going to want me to import java.util.scanner. We've used scanner before, right? Way back when? Okay. So scanner is our easy way of reading things in from the user. So we'll prompt. There is. Would you like to see the hard way? All right, well, here, I'll show it to you. Let's read this in first and show this works. Please enter a expression. And then we'll prove we read it in by just printing line back out. Okay, so we'll build our scanner. We'll prompt them to enter an expression. We'll actually read in that expression from the user. So once I type crap in and press enter, that's when next line finishes. So this guy blocks until we press enter. And then we'll print out whatever was read in. So go ahead and run this real quick. So we're going to do 1 + 3 × 8, whatever. Press enter, and it spit it back out. So we successfully read crap in. Okay, no big deal. All right, now the old school way of reading stuff in from the user. We can do the old school way, then the old school way if you want. We've done the old school way in the compilers class where we read things in one character at a time. So I'm going to go ahead and comment out all this. And what I'm going to do is I'm going to create an input stream reader. Whatever, called input. Is this going to be a new input stream reader system.in. It's going to want me to import java.io.input stream. Okay, then I'm going to create a, so what this will let me do, just to give you an idea, okay, here's a situation where I'm going to create an infinite loop to show an example. So I created my input stream reader, then I just created an infinite loop. And this guy's just going to, whatever I type in, input.read, it's going to spit back out. Okay? Did hit play, did I not? Does it not like me doing the random? Why isn't this running? It's very strange that it wouldn't run until I had it display something. And when I press enter here, it's actually reading in a carriage return, and it's displaying it. So see how it's reading in one character at a time? Okay, so that might be beneficial for us in some circumstances, but in this circumstance, well, in most circumstances for us, we'd like to read things in one string at a time, because Java is a string-based language. So what we do is we create something called a buffered reader. And we build that out of our input stream reader. So now we need to import java.io.bufferedReader. Okay. So we have a function inside buffer reader called readLine. Class method or instance method? What?
Instance.
How do you know?
Is you use it calling the instance of buffer reader called console.
Okay, so it's an instance method because we're calling it using an instance of the buffered reader class. So this must be an instance method that lives inside of buffered reader. So does that mean that when this guy's defined, it would have a static or would not have a static?
Would not.
Would not have a static. Okay. Now I'm reading things in one line at a time. Make sense? Okay. So this is our, oh, and actually, just to show you an issue we have with this. Console.readLine actually throws an exception. So we actually have to surround this in a try catch or have our main throw an exception like we had before. Scanner does not. Okay, so here's our new way of doing it. Everything's wrapped inside of Scanner, as opposed to before we had to kind of piece it together with Legos to read something in. Not that this is that huge of a deal, but reading something in from the user might be something that would be relatively common, so we should have a nice little power tool for doing it. Okay. So we will read in our expression, and now we want to tokenize that expression. Now we have not written. Have we written our own tokenizer in here, or have you only used string tokenizer?
Only use string tokenizer. I don't remember.
So if we have a string s that looks like 1 plus 4 minus 6 times 2, and we want to split that up into a bunch of tokens, how would we do it? And where would we store them? Let's start with this. How many tokens are in S?
7, 8, 7.
So we have the 1, the plus, the 4, the minus, the 6, the times, the 2. So 3, 4, 5, 6, 7. Okay. I'm going to write a method out here. Static, we'll make it void for right now. Tokenize, and this guy's going to take in a string expr. How many tokens are in expr?
4. Well, no.
Now here's
the
the expr. Yep. Everything up here does not matter, so don't even look at it. It'll just confuse you. How many tokens are in expr? What is in expr? Let's start with that. Some string. expr has some string in it. How many characters are in that string? expr.length number of characters. How many tokens are in that string? Keeping in mind that our expression syntax does allow us to have numbers that are larger than one character. So we can have 117 plus 84. So do we know how many tokens are inside of expr? We don't. But our job here is to write a tokenizer. So we're going to tokenize up our string, which we can do, but we don't know how many tokens we're going to run into. What are we going to do with each of those tokens? We need to store them somewhere, right? I mean, we're going to use those tokens eventually, correct? Okay. What are our options for storing tokens? In this case, each token will be a string, right? Where can we store these guys? Okay. String array, makes sense. Why is that going to be difficult?
We don't know how long.
Go ahead. Once again, we don't know how many tokens. So we can store our tokens in a string array. We don't know how many tokens we have. So how can we build a string array that's big enough? It's the chicken or the egg problem, right? Well, how do we solve this problem? Go ahead. Oh, use linked list. Why would linked list be a good solution for this? Can hold an arbitrary number of things, right? Okay. Now, I'm going to go ahead and introduce you to the linked list data structures built into Java. Okay? For convenience reasons here. Get rid of those extra inputs up there.
If you have extra inputs that you don't use, does that affect the performance at all?
No. Just size of the executable. Because you're importing those into that library in there and just not using it. Okay.
Would it take longer to open it up?
Maybe marginally. Yeah. But you have enough extra things imported in there, yeah, it would make a difference. Okay, so giving you an example of linked list. So there exists in Java a class called linked list. Correct. All right, so we have this class called linked list. I'm going to create an instance of the class called LL. Then I'm going to go ahead, I'm going to say LL dot add. Actually, we don't need that version of add. I'm just going to do, don't we just have an add? Oh, here, we'll do add front. Oh, hold on. Hold on. We have an issue here. Well, just bear with me for this for a second. I'm going to create a java.util. Is it util? I thought it was in java.util. I'm going to go to my linked list up here. I'm just going to refactor it. I'm going to hit rename. We're going to call this guy linked list 2. And it's going to go through and it's going to update everything inside of this guy to be called linked list 2. So that's what refactoring does. Refactoring is the software engineering word. So tools that have refactoring built into it allow you to easily change things, and it goes through and changes things all throughout. So, for example, if I go to head here, and I should be able to refactor this. I refactor head to be called the head. You see how it's changing in all the other places? Changed down here as I was typing it.
It changes in between classes too.
Yep. I believe so. Especially, certainly if there's inheritance. Okay, so introduce you to refactoring a little bit there. Now I can come in here and I can create my linked list. LL is equal to a new linked list. And this wants me to import java.util.linkedList. All right, now I'll say ll.add. And I'll go ahead and add blah ll.add hello. Okay. Now I'll say ll.get. So we can get something for a specific index. These are things built in just like we kind of wrote in our own, right? But notice that what comes out is an object. So the default linked list built into Java is a generic linked list that can hold anything that is an object. What's the advantage of that? If we had written our linked list to hold objects rather than ints or chars, what's the advantage of doing that? Okay, we can put any type of variable in there. Is that completely true? Or could we just put any object type of variable in there? Don't let me trick you. So you're saying by making the linked list a list of generic objects, it allows us to put anything we want in there, correct? And then I asked the question, does it allow us to put anything we want in there or just object types? Really what that leaves out is, can I store primitive types inside of objects? If I have a linked list that takes a primitive type as a parameter, or I'm sorry, if I have a linked list that takes an object as a parameter, so I'm going to say ll.add, and I pass it a char, will that work? Chars, ints, longs, bytes, shorts, booleans, doubles, floats. What are all those guys? Primitive types, right? By definition, primitive types are not what? They're not objects. Remember, we have two types of variables in Java. We have primitive types. What's a primitive type? Built into the language, only can hold a value. Then we have object types. What's an object type? It can hold 0 or more values and potentially do more. Some of them are built into the language, and we can create literally an infinite number of them. We can write our own objects, right? Okay, so if I have a linked list that accepts objects, can I pass it a primitive type? What I'm really asking here is, can I do this? Can I say object C is equal to 5? Can I say object C is equal to A? Object C is equal to true. Clearly, it seems like it's working, right? Why? Is this guy an object type? No, it's not. It's a primitive type. This is an object, right? Can I say int a is equal to hello? So I can't create a integer named a and store an object in there. Can I say int a is equal to c? Doesn't like that either, right? Says, got to add cast. So doesn't know what this guy is. So I can't say int a is equal to c, but I can say c is equal to, I can say int a is equal to 5, c is equal to a. I can't say a equals c, but I can say c equals a. C gets the value of a. Why is that? I'm going to give you a hint. The answer to this is something similar to what we understand about the toString method. What can you tell me about the toString method? What's the toString method used? Who uses the toString method?
Print.
System.print and println, right? So our default ways of printing crap to screen leverages the toString method. Why? How many different versions of the print and println method are there? Ish. Actually, you should be able to tell me exactly how many. Okay, so we have one byte, short, int, long, char, float double, boolean, and then object. So 9. Okay, I actually think there's also one for strings. 10. Although I'm not sure why I know why there's one for strings. Let me just double check that. I'm almost positive there is. Well, I know from memory. I'm just trying to think why there is one for strings. I don't think you need one. So hopefully I'm wrong. Hopefully my memory is failing. Okay, print. We have 1, 2, 3, 4, 5, 6, 7. Oh, I forgot the one for char array. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's actually interesting. There is one for ints, there is one for longs, but there's not one for bytes or shorts. I'm supposing they just treat those as ints, which is interesting. Why doesn't it just treat it a long as an int? I don't know why there's one for string when they have one for object. The character array one makes sense. Just interesting. Okay, so we have a bunch of different print and println methods, right? Most of them print out primitive types, right? Why do they print out primitive types? We're actually going to see here that there's a good reason why we actually only need one println method. We're probably seeing the evolution of Java, where they added a feature to the language before or after they had already created a structure for the language. I'm saying I think we only actually need one print method and one println method to cover all. What's it called when we have more than one method with the same name but a different number and type of parameters? Polymorphism. Okay, so we have a bunch of different println methods. How does toString play into there? Where was the first toString method? Who owns the first toString method? Object. Our first object also owns the first toString method. And what does the object's toString method do? Well, just like toString indicates by its name, it returns a string representation of that object, right? An object's toString method does what? What does its string representation look like? Memory address looking thingy, right? Okay. So our default toString method prints out memory address. Now, string has written their own toString method, correct? If I come in here, I'll go to string. Down here at the bottom, here, let me make this a little bit bigger. Can we see that ish? Okay. I'm going to scroll all the way down to the bottom here to the inherited methods. Well, that's interesting. It didn't actually list it here. These are all the methods it got from the object class. Really, toString should be in here. I don't like the way they've done the documentation. It does inherit toString from the object class, but the string class overrode that. To do its own version of toString. It still inherited a toString. Therefore, inside of here, we could say super.toString. If we were the ones who wrote string, we could say super.toString. We've done it ourselves, right? We've called upon our parents constructor to give us the weird memory address thing, followed by our payload. Okay, so I don't like the way the documentation reads here, because we did inherit a toString method. We're just choosing to have a more local one up here for strings. If print and println both use toString, do we need to have a version of print that takes an object as well as a string, or could they both just take an object? Println calls whatever was passed to its toString method. That's what it does. So there is not a reason that we need to have a print for strings as well as objects. Just object, the most generic version of it, because objects are guaranteed to have a toString method. Correct? All objects are guaranteed to have a toString method. Even if the object doesn't choose to write one themselves, they'll inherit one from the top level parent. All right, so already found one bug in Java's documentation. We don't need two of those guys. In fact, I bet you internally, the one that takes a string might just call upon the one that takes an object. This might just be for public viewing to make the system class look more amazing, I guess. Like, here are 14 different methods that do the same crap. Like, you know, pal, you could have written it in one. And we're getting there. Okay, so toString is used by print and println to display the string representation of an object to the screen. ToString returns a string representation of an object. That's what that method does. Print and println utilize that method to actually display it to the screen. Okay, now I ask the question, back to our code here. I can say int a equals 5. I can say object c equals a, but I can't say int a equals c. Well, here, why don't we say int b is equal to c, so I don't have two variables named a, and we see it's still a problem. Why is that? And the hint I gave you is that it's related to that similar logic that went into ToString. Remember, Java is a language that its goal from day one was to simplify things for programmers. An older language like C++ was substantially more difficult to program in, even though the languages are almost identical. C++ allowed you to take more wrong turns. It yelled at you for things that from your perspective seemed right, but actually were wrong, actually was wrong. Java has the benefit of yelling at you far less. I know some of you don't necessarily believe that, but it does yell at you less. I actually think from a teaching perspective, it's a bad thing. Once you are a seasoned programmer and you've done this stuff a zillion times and you understand why things are working the way they're working, I'm all for the nice power tool, right? I mean, let's make our lives easier. But before that, Java hides so much from us that I think we take for granted what it's doing and we end up not actually learning what's happening. We learn the Java way of doing it rather than the real way of doing it and appreciating Java for what it's hiding from us. Okay, so this is one of those situations. I can say int a equals 5. No harm, no foul there. I have an integer named a. Well, I have a variable named a, capable of holding an int. I'm going to put an int in there. Makes plenty of sense. Right here, I have a object. I have a variable named c, capable of holding an object type. And I'm going to shove an integer in there. Work just fine. Okay, that seems confusing. Now I'm going to have a variable named b, capable of holding an integer. I'm going to shove an object in there. Nope, doesn't like it. So I can shove an integer into an object, but I can't shove an object into an integer. Clearly, that's all. Everything I just said is factual. The question is why? Java is doing something for us that is creating this confusing situation. And once we understand what they're doing, it makes plenty of sense. Everything has to do with context at some level, so let's just say no. In the context of your question, the answer is no. Another hint?
Sure.
If I want to print out S in uppercase, what would I do? System.out.println S.to uppercase. That'll print out the entire string in uppercase, correct? Has the string actually changed, or did it just change in that one little instance? Okay, so S is not permanently altered to be uppercase. This just gives me the uppercase version of S. Okay? How would I print out the H in uppercase? Regardless of which one you give me first, I'm asking you to tell me two different ways to print out the H in uppercase. That is the character at bucket 0.
Use char at.
Okay, char at bucket 0 will get us that character. So s dot char at 0. That gives me the h. How do I print that h out in uppercase?
Isn't there a character dot to uppercase?
Character dot to uppercase.
And then 0, yeah.
Okay, that's one way.
You can do s dot to uppercase, which will return the string representation uppercase, and then do that char at 0.
So same thing we did above, but instead of printing out the entire string, we're going to print out dot char at 0. Convert the string to uppercase first, then give me the first character, which is in uppercase. Or give me the first character and use the character class to convert it to uppercase. I have given you your hint. Like another hint?
I'm willing to take a shot at the answer.
Okay.
Since object...
I'm willing to take a shot at the answer. What are you willing to risk?
Not a whole lot, actually.
Right, go ahead.
Since object isn't a primitive type, does it have a method that it's calling to basically initialize what you input as an object?
Give me an example.
So two lectures ago, I think when we started doing, just before we started with the int prototype, someone's suggestion was to take in the prototype and then initialize it as whatever variable type we needed it to be.
Okay, so kind of like what we did with the in our linked list for accepting both ints and chars.
Yeah.
Okay, that makes sense, but we're not actually calling a constructor here. In fact, once upon a time, I said something like creating a string I called this syntactic sugar, right? Because usually when we create objects, we use the new keyword. Well, I said the only object that we have this special syntax for is strings. Well, it seems like we kind of sort of have that special syntax or something similar to that for objects. This is syntactic sugar. But in any case, we're not actually calling a constructor here. But your feeling is that it's doing something. The constructor that actually is getting called is doing something to this value.
Right.
Okay?
Just a random kind of question.
Okay.
If you cast C as an integer, would it work then?
If I cast...
No, for the B equals C. If you cast it as an int, would that have it equal?
As an int like this?
Yeah.
No.
Okay.
Another hint? You're not horribly far off. But we're not, we got to get some details in here. So I'll give you another hint. decimal from string. If I have the string s is equal to 138, how do I get the integer 138? That is, when I say system.out.println s plus 5, as it currently stands, it's going to print out what? 1385. Because this plus sign is getting read as the concatenation operator, because at least one side of it has a string. But I actually want to get 143, the number 143. So how do I convert s from a string into an integer?
Integer dot license and pass in s.
That?
Yep, and then add the 5 and that.
So this will boil down to 143. I won't print it, but I'm in a constrained situation here because I chose the wrong slide set where it has the 2 columns. Okay, so we have a class called integer that can convert strings into numbers. We have a class character that can convert a single char to an uppercase. Why does the character class and the integer class exist? To do things to primitive types. Why? Primitive types can only hold a value. That's it. They can't do anything to themselves. No magic tricks. Okay? So we have all of these classes to allow us to operate on our primitive types. Correct? Let's see if we can... Well, let me try. I'm going to try to do something here first. I'm going to try to print out the object version of C. I'm going to wrap this whole thing in parentheses. I don't think it's necessary, but I'm trying to force an issue here. No, that's not what I wanted. I could definitely show it one way. I'm just trying to see if I can make it work in another way. I think we can access that out here. No. That's a private variable inside of... Okay, let me do it this way. If C instance of integer kind of, for some reason, reminded me of that. Have you seen the, I think the commercials like freecreditscore.com or something like that? It's like the game show. It's like, you know, which credit score thing are you using? I'm using freecreditscore.com. It's like a race. Which one are you using? Some other credit site. That isn't obviously the loser. But I always root for her. Okay.
One day.
So, I'm putting a int primitive type, A, into a variable of type object, capable of holding an object named C. Then I'm asking the question, is C an instance of integer? Not the primitive type integer, but the object type integer. and it printed out, yes, I am an integer, as opposed to I am something else. That make sense? So what is happening? What is magically happening to A here? There's some syntax that's missing. This is syntactic sugar. Help me fill in the blank. What's actually showing up there? That. That's what's happening. So by me putting a primitive type on the right-hand side of the assignment operator, it's calling upon the integer constructor and saying, I need you to build me something that is in fact an object. And since it is in fact an object, I can store it inside of a variable capable of holding an object. So take this primitive type, wrap it inside of an integer class. This is like using a node where A is the payload. You're creating a, taking a Ziploc bag, throwing the integer in there, have an object. Passing that object into C, now we can use it. Now, if I create a So I'm going to create an integer named I and build it using my int a, and then print out I. We'll see that it shows the 5. What does that mean about the integer class in terms of its toString method? The integer class is an object, correct? Therefore, it gets a toString method from its parent. And who's its parent?
Object.
Somewhere in the lineage, it's object, right? It's possible that integer has an intermediate parent. We'll check here in a second. Well, let's just check now. But we know at the very top of that inheritance tree is going to be object, correct? Here's integer. Okay, yep. So a integer is a number, which is an object. Okay? So we have this intermediate class here called number. Oh, that's an abstract class. What does it mean for a class to be abstract?
Don't have an instance of number ever.
Yeah, you're not allowed to create an instance of number directly. Okay?
That would make sense because there's different kind of numbers, but you would never want a general number.
Correct. And actually, this is even a bigger argument as to why they don't need all those print and println methods. In any case, when I created integer I and then I printed out I, it printed out the number 5, not crazy memory address. What does that say about the toString method of the integer class? Did they write their own, or did they take the one they got from object? It's possible they wrote their own in the number class. But it's clear to say that the toString method is not the one they got from object, right? The toString method that would have been inherited from object prints out a memory address. This guy did not print out a memory address. It printed out the value 5, the actual int value. Okay? So what is happening whenever we try to stick a primitive type into a generic object? It's automatically wrapping that as a appropriate object. Similarly, we tried to put a true in there, and it worked just fine, correct? If C instance of integer, I'm doing this on purpose, So we'll create our object C, stick a Boolean value into it, then ask, is that guy an integer? We'll see it comes out as something else. Is it an instance of Boolean? It is. It says integer because that's what my if it's Boolean prints out. It prints out integer. Well, let's go look at Boolean. Boolean has a direct descendant, which is object. So clearly what's happening here is whenever we try to stick a primitive type directly into an object, it's wrapping it. Now, can I say string s? There, we'll do it up here. Equals true? I can't. It's yelling at me. Why not? S is an object, isn't it?
That's a string.
String is an object, isn't it? And we'll go look at it right here. Here's string. String's parent is object, so string is an object. Just as object is an object. But I can put true inside of object, but I can't put true inside of string.
Because it doesn't use that same, like, syntactic sugar this object does.
We have discovered another special case. Just as strings, saying string s is equal to hello is the same thing as saying string s2 is equal to new string. This syntactic sugar is happening for strings. We've seen it over and over and over again. For objects, object C equals true is the same thing as saying object C2 is equal to new Boolean true. Does that make sense? More syntactic sugar. Now, what's good about that, though, from our perspective, is we can use the generic linked list class. So let's get back up here to our linked list example in our last couple of minutes. And I'm going to say ll.add blah, ll.add hello, ll.add true, ll.add 5. And then I'll go ahead and I'll create a loop that goes through it. Let's see, for object C in LL. We've done for each loops in here, right? Okay. System.out.println C. That prints out the contents of our linked list. Need to see something here real quick. Okay, that's good. I'm just going to quickly build us an int payload for no other reason than it's a another object, but it's an object we built. So I'm going to say ll.add a new int payload, and I can pass it whatever integer I want to pass it. And now I'm printing out all my values. We see that int payload gives us its creepy memory address. Why is that? Int payload did not write their own toString, and its parent is payload, which also did not write its own toString. And who's payload's parent? Object, which does have its own toString, which prints out creepy memory address. So as we have this right now, when we put stuff into a linked list and get it out, it's always storing things and retrieving them as generic objects. If I want to store a specific type of element in there, when I create my linked list, I can say this is a linked list of strings. Okay, this syntax is called generics. It's a feature of Java. So I can say I want this linked list to actually be a linked list of strings. Now everything we pull out of there, so notice that it's yelling about all these new adds. Why is that? Because if I say ll.add, notice the only thing that add takes is a string now. Where before, when I left the generics off, ll.add took in an object. Make sense? Okay, so we'll come back next time. We'll actually implement our math thing with stacks, but hopefully we've seen an interesting what's under the hood thing with Java today. Okay? All right, I'll see everybody on Thursday.